Hello friends. Now in this video we'll see how to create a proof tree for a given propositional logic formula. This is a proof tree in propositional logic. Now consider that I have a formula given like P P implies Q and that implies negation of Q implies negation of P. So how do we create a proof tree? A proof tree we create it from down, that is we consider the given formula initially as false. That is, there is nothing that is true and the given formula is false. P implies Q implies Q, negation of Q implies negation of P. For this given formula to be false, we should remember that in this if there is a implies, then it means that it can be false. Now consider that this formula is false, this part is false. When can this part be false? A implies function will return false only when there is P implies Q. When P is true and Q is false, P implies Q will be false. So here in our formula, P implies Q is true and negation of Q implies negation of P is false. So we go up a level, we climb up the tree and we have some conclusions now telling that which says that a true part is P implies Q. We write true part with this within this angular brackets, and here also we have written there's nothing that was true. Initially we took our formula to be false. If this should be false, then this should be true and this part should be false. So this is what I'm writing here, and the false part will be I'll be writing in a separate box. Okay. So we came up one level over the tree. Now we should consider still more. That is, when will this be true? When will this part be true? This part will be true when in many conditions, like P is there and Q is there. When is P implies Q true? P implies Q is true when Q is true or when P is false, whatever this side it is, this will return true. When P is false, so I will consider that part first. So I'll write when if I consider this as true, then I'll have nothing that is true in the upper level, because this can be like this is false implies star anything. So I will consider that this nothing true that can be concluded from this part, and I can conclude that P is false. P is false, comma, the remaining part I'll write as it is. this part. P is false, and negation of Q implies negation of P is false, because we know that this part is true and this part is false. So this false remain as it is, and additional false part will be added from the true part. Now we consider this formula. The other part, that is, I have considered F star T. Now I'll be considering star T for true part. So again, when I consider, this is when I had considered F star will return true. Now this will be for when I consider this and I get this formula, this conclusion, and when I consider star T is true, that is this part, I get this formula. What does this tell? That is, P can be anything, Q should be true. So Q should be true. The true part is Q should be true. And the false part is this one, will go up, and there's nothing concluded that to be false from this part. So this I'll write as it is. Negation of Q implies negation of P. Now I can go one more level up for this. For this to be false, P is false, I can write it directly. There is nothing that is true. This is false, so P is false, comma. For this to be false, this should be true, false. So negation P is also false. So this is closed. This can't be there. P and negation P both cannot be false. And in this part, we can see, if we go one step above, we can see that Q will remain as it is, and for this to be false, negation Q should be true and this should be false. So negation Q is true and negation P is false. I left here. The negation Q should be true. I had left here. Negation Q should be true. So here also we get a wrong conclusion, that Q is also true, negation Q is also true, which cannot be the case. So this is closed. So the proof tree is something like this.